The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Example finding standard heat of formation. As it says here, when steam reacts with carbon at 1273.5 kelvins, what is the standard heat of formation for the following reaction? Now, just as we did when we were working with Hess's law, what we're going to need to do is we're going to need to take these individual reactions, right, rearrange them until we get our target reaction here. Wonderful. Now, taking a look at the individual reactions, we see here that the first reaction we can leave as B, but the second and the third reaction, what we're going to need to do with those two is we're going to need to flip them and we're going to need to multiply them by 1/2. Now, not only do we multiply the reactions, but we also need to multiply the standard enthalpies of formation, their standard enthalpies of formation by 1/2 as well, and we also are going to need to flip their signs. Thus, when we flip a reaction, so when we flip these two reactions, we also need to flip the sign here. So that's going to be positive and that's going to be positive as well. I've already gone ahead and made the necessary adjustments to reaction 2 and 3 on the coming slide. Let's go ahead and take a look at that. Wonderful. Now, if we see here, right here is our target reaction up here. I'll just highlight that. Now, if we see here, for our second and third reaction, we've gone ahead and we flipped it and we've multiplied it by 1/2. Furthermore, the standard heat of formation values, we've also gone ahead and flipped the signs on those, and we've gone ahead and multiplied that already by 1/2. Wonderful. Now, if we just go ahead and we cross out our like terms as such, and also the carbon dioxide, we can as well, and and that's it. We are left with our target reaction. Now, let's just go ahead and write this out, and in doing so, just the H2O as well, right? Now, what is next? We just need to write down our carbon monoxide as such, plus our hydrogen gas as follows. Now, what about the standard heat of formation? Well, we're a little limited for room, thus I'll just go ahead and write it down here. That's just going to be 131.3 kilojoules. There we are. That is our answer. Now, as we can see, our reaction is going to be endothermic, and for this, what our value here is telling us that 131.3 kilojoules of energy is needed for our reaction to proceed to the right up here, right? And there we are. Okay, great. We're now ready to move on to our next slide. Wonderful. There we go. Now, should you like, you can pause the video now and try this one on your own, but for the rest of us, let's go ahead and proceed to solve this problem. Let's begin here with reading our question. Find the standard enthalpy of formation for acetylene. And here we have our reaction, and let's take a look at the individual reactions that we have. We see here that we're going to need to multiply our first reaction by 2. Since we have 1 mole of hydrogen gas here, we can leave the second reaction alone. And to get a mole of acetylene, what we're going to need to do is we're going to need to flip the third reaction, and we're going to need to multiply it by 1/2. And again, don't forget to make the same adjustments to your standard heat of formation values as well. I've gone ahead and made the necessary adjustments. Let's go to our next slide and see what that looks like.